Okay guys, welcome to the first homework tutorial that I'm doing this year. My goal with this is to allow you the opportunity to take a look at some of these videos and get some help on the homework while you're doing the homework. So if you ever get stuck on the homework, just take a look and try to watch some of these videos. So the first example I'm going to do is how to find all of the zeros of a polynomial function if you're given one zero. In this case, particularly a real zero. If you notice here, -3 is a real number. So I'll talk to you in another tutorial how to handle it if it was an imaginary zero. So we'll get to that later. So I know that -3 is a zero. I also know that I'm going to have a total of 3 zeros. The fundamental theorem of algebra tells us that the degree of a polynomial represents how many zeros we will have. So I would recommend that you always take a look at that degree first so you know, look, I've got to go find 3 or I have to go find 4, whatever. In this case, I have 3, but I was given 1, so that means that there's 2 out there that I need to go find. So to find those, we're going to use synthetic division. So if we're going to use synthetic division, we need to take the 0 that was given to us, which in this case is -3, and we're going to put that outside of our L-shaped synthetic division setup. As always, go through the polynomial that's given to you and look to see if you're missing any terms. If you are, you need to put 0 for a placeholder. In this case, we are not missing any terms, so I'm going to line them up. 6, 13, -14, sorry about that, and 3. Now, before we do the synthetic division, I just want to go back to a point that we had made in previous lectures, which is if something is a 0, we know that the remainder will be 0. So before I start this problem, I'm going to put a little 0 here. If I'm doing synthetic division correctly, I'm going to get a remainder of 0. So it's kind of like a check within the problem to tell me if I'm doing it right. So remember, we add vertically, we multiply diagonally. So I drop down the 6, multiply by -3, gives me -18, add, which gives me -5, multiply, which gives me 15, add, which gives me 1, multiply, which gives me -3, and as you can see here, I did it right because my remainder does come out to be 0. So we're ready to move on. Now revisit the fact that if the first term is x cubed, which it was in this case, this would make the first term 6x squared. It would make the next term -5x, and it would make the last term +1. I'm going to set that equal to 0. Now the good thing here is I've taken it from being a cubic polynomial to now being a quadratic. And we know after the previous chapter that we can solve any quadratic in a variety of ways. We learned 5 in particular. We learned the square root method, we learned factoring, we learned completing the square, we learned the quadratic formula, and we learned graphing. So at this point it's up to you. I personally would try to factor it. But if you want to go to the quadratic formula, by all means go for it. So if I try to factor this, the technique I'm going to use is essentially guess and check. I'm going to come up with factors of 6. In this case, I'm going to try 2 and 3. I would either try 2 and 3 or 6 and 1. And I'm going to do factors of 1, which that's pretty easy. The only thing that multiplies to give me 1 here is going to be 1 and 1, or -1 and -1. So I'm going to multiply the diagonals to see if this works. So 2 times 1 is 2, 3 times 1 is 3. So I end up with 2 plus 3. The problem is that gives me +5. But if you look at the middle term, I need -5. So I need to make a little adjustment. Since I need -5, that would tell me that these 1's need to be negative. So therefore, I end up with the factors 2x minus 1 and 3x minus 1. And that is set equal to 0. Now that it's factored, I take my factors, set them equal to 0, and that'll tell me what the missing 2 zeros were. So I'm going to take 2x minus 1 and set it equal to 0. I'll go very quickly with that. So 2x minus 1 is equal to 0. So I get x equals 1/2. And if I set 3x minus 1 equal to 0, I get x equals 1/3. Okay, so therefore, at this point, I found all three zeros. I was given -3, so I want to include that in my solution set. I just found 1/2, and I just found 1/3. I was looking for 3, and I have now found all three. Now, a great check is to take a look on the calculator. So here's what I'm going to do. I'm going to take that original polynomial, which was the 6x to the third plus 13x squared, etc. I'm going to take that and I'm going to graph it. So I'm going to come over to here and I'm going to insert that original equation. So in the upper left hand corner you can see me typing this in. So I've got plus 13x squared minus 14x plus 3. Now remember, you've learned that zeros occur on the x-axis. Well, at least real zeros occur on the x-axis. So let me zoom in on this x-axis for just a little bit here. Now, if I were to zoom in on those x-intercepts, look over here, I'm getting -3, 0. That was the one that was given to me. Now let me go over to this next one. I'm getting 0.3 repeating, and hopefully you know that that's 1/3. And then the other one is at 0.5. So let's go through those again. -3, that's what we got for the given one.